let's graph some piecewise functions. So, in order to graph a piecewise function, you have to think of what it really is. It's a function in three pieces, but it's really like three separate functions. And for example, 2x plus 5 is only present when x is less than negative 3. So, the first thing you want to do is you can see I have two dividing lines here. So you want to write your dividing lines, which is negative 3 and then again at 2. And then you want to think about graphing these. Now, if I was to graph 2x plus 5, right? If I was to just graph the line, the 5 is the y-intercept. This is mx plus b, and the slope is 2, meaning it would go up 2 and over 1, and it would go the opposite way, and you just have a line, right? And it would go down here like this. But we're not looking at that full thing. What we're only looking at is when x is less than negative 3. So in order to do that, you want to think about, well, I'm still going to have 2x plus 5 here, but only when x is less than negative 3. Also, on my dividing line, I'm going to need an open hole for the y value at negative 3. So I can go ahead and input that into 2x plus 5, which is going to give me negative 6 plus 5 is negative 1. So now I'm going to go ahead and put an open hole here, and I'm going to be going down 2 and over 1, because that's the same actually as if we go this direction, our slope is 2. So notice I've graphed this now for all the values when x is less than negative 3. Put your arrow here, that means it would go to negative infinity. Next I have one that you should recognize is a absolute value function, and it's absolute value of x minus 2, which just means that it's the absolute value shifted down by 2. So you actually already know that the y-intercept here is negative 2, because if you input 0, well, you get negative 2. So I can go ahead and put that. Now I want to figure out, well, where is it at negative 3? Because that's my dividing line. I'm going to have a solid dot there, and I'm going to have an open hole here, or open dot, at 2. So if I input this into this function, absolute value of negative 3, remember, absolute value just always turns things positive, so that's just 3 minus 2 is 1. So absolute value of negative 3 is going to be 1. I'm going to go ahead and put a closed hole here. And then if I was to input 2, well, that's absolute value 2 minus 2. That just gives me 0. So I know it's going to be an open hole here. Let's do that a little better. We're going to have open hole at 0 for y. So now I can go ahead and draw this, and it should look like a V, just like absolute value, just slid down by 2 units. Okay, so now I have this part of the function from negative 3 to 2 for x, and then when x is greater than or equal to 2, well, that's the easiest part, because that's just a horizontal line. Whenever you see a 4, that just means it's a horizontal line, and so that means when x is greater than or equal to 2, you got a horizontal line, and you just put an arrow there to signify that it's going to positive infinity for x. All right, so now we're done with this one, and let's try another one. Okay, one more piecewise function. So very similar here. We got dividing lines at negative 1 and 2. So I already put 2 vertical lines there so we can see that. Let's label our x and y axes. Okay, so now when x is less than negative 1, we have a horizontal line at negative 2. So this should be easy. We're going to put an open hole at the dividing line when x is negative 1. And our y value is negative 2, and we just have a horizontal line going this direction. So that part is done. Next, notice we have x squared minus 2. Well, that's just a parabola, and it's going to also have a y-intercept of negative 2. So as I go through here, if I was to input 0, I would get negative 2. And if I input negative 1, at our dividing line, that's going to give me 1 minus 2, which is equal to negative 1. So I'm going to go ahead and put a closed dot here for negative 1 is less than or equal to x is less than 2. And then I'm going to input 2 again to figure out where it's at when x is 2, what's the y value. So that's 4 minus 2 equals 2. So I'm going to go ahead and put that dot here, and that's going to be open dot. And that's going to be right here. So notice I have part of a parabola. If it was to keep going, right, it would keep going like this, and you would have the rest of the parabola. But that's not what we're doing. We're doing a piece of the parabola that's just one piece of this function, this overall function f of x here. So we have from -1 to 2 graph. Now we're done with that. And we got one last thing. We got a linear function here, or a line right here, and we're going to go ahead and put that one in blue. Now, if you want to think about this one, again, if you were to graph the whole function, you would go down to the y-intercept -4, and I would go up 2 and over 1, and I would graph this line, right? But we're not looking at that whole thing. We're only looking at when x is greater than 2. You never want to have two functions vertically because then they fail the vertical line test. So you should always make sure that here you notice I have one part open, close. This is open, so this next one is going to have to be closed. So now I'll go ahead and just put in 2 because that's where my dividing line is. I get 4 minus 4 is 0. So that's how I know I put a closed dot at 2 comma 0. And next I know my slope is 2, so I'm going to go up 2 and over 1. Or you could input x equals 3. You would get 2 times 3 minus 4 will give you 6 minus 4 is 2. And either way, you have a line going up with a slope of 2, and you put an arrow because that one would go towards infinity. And now you're done with the second one.